Hello, this is Dr. Eduardo D'Alessandro from Brazil, São Paulo. This is a video comment for our 7th week of the PPCR course 2021. This week we've been introduced to the basics of statistics and sure enough to the normal distribution curve. And this curve is also known as the Gaussian curve after a mathematician named Carl Friedrich Gauss. And I was very interested in studying his life, for I wanted to understand how did he come up with this normal distribution curve. It's a very interesting curve, a bell-shaped curve with symmetrical, with tails, with a lot of properties that can be calculated and that depict quite well many natural phenomena. So I was reading about Carl Gauss, and has a very interesting life. He is considered the foremost mathematician of our time, the greatest one of all. And his struggles with mathematical problems begin a very, very young age, actually. His own birth date was a problem that he solved, for his mom was illiterate and she was unable to pinpoint his exact birth date, but later she could recall that he had been born on a Wednesday, 8 days before the Feast of Ascension, that is held 39 days after Easter. Well, the problem is that Easter is held on the first Sunday after the full moon that occurs on or just after the spring equinox. So this is quite a variable date, and it was a very old problem to solve. When did the Easter Sunday would fall every year? So he came up with an algorithm that could predict the Sunday Easter date in any given year. So that was very interesting. Many anecdotes surround his early life. They say that by the age of 3 he was able to correct his father on a math problem, and also in his first year of school, maybe 7 or maybe 10 years of age, the class apparently was misbehaving, so his teacher proposed as a punishment a challenge, and everyone should add up all the numbers from 1 to 100, and Gauss was able to provide the correct answer quite quickly. Apparently what he did is that he realized that if you streamlined every integer, like 1, 2, 3 until 100, and then you get the first one and the last one and add them up, like 1 plus 100 will be 101. Then you take these numbers out, then the first number now it will be 2 and the last one would be 99. So he add them up again, 101, and again 3 plus 98, 101, until the last pair, that would be 50 plus 51, and again 101. So what he did actually was just to multiply like 101 50 times, and he got the answer 5050. Quite a genius. But again, the normal distribution curve was used to solve another problem. They had this problem of how to navigate open waters when you have no landmarks. So the sailors, they would rely on the positioning of the stars. What happens is that these measurements of the positions, they include errors. So Gauss was trying to clean them up, clean the errors out, and find the most accurate measurement of the star positions. And he realized that the best way to do it was to take many measurements and then do the arithmetic mean of such measurements. And this number, this value, would be the most accurate one, like the least amount of errors. And in this process, he envisioned the bell curve. So this is quite interesting. Still not sure why this happens. I guess it has to be with randomness, the inclusion of randomness in this equation. You have some fixed measurements, but you have random errors. Um, and one thing that also brings me to think about randomness is the central limit theorem. Um, this theorem tells me that whatever distribution you have on your population, could be exponential, could be constant. If you take a random sample of this population and you calculate the mean of this sample, and then you have multiple samples, calculate the means of these multiple samples, the more samples that you have, and you have the means would be distributed as a normal distribution. So I guess randomness is at the normal distribution. I guess normal distribution implies randomness, but this is up to debate, I guess. So please comment if you see some falls in this thinking. Hey, cheers. Bye bye.